In this video, we're continuing on with the adding and subtracting rationals worksheet on the KutaSoftware website under the Infinite Algebra 1 section. Now remember, when adding or subtracting rationals, we need to have the same denominator, and in number 9, we do not. But first, let's simplify. 7x over 2x, we can cancel out an x from both the numerator and denominator to get 7 over 2, and then we'll subtract x minus 2 over, now looking at the denominator of our second rational or our second fraction, 20x, we can pull out a 4 from each of those terms to get 5x plus 4. And that's because 4 times 5x is 20x, and 4 times 4 is 16. So now, remember that I said we need to have a common denominator in order to add or subtract. And 2 is not the same as 4 times 5x plus 4. However, we'll be able to multiply 7 halves by some quantity 1 in order to manipulate it. So if we take 7 halves and multiply it by 1, where that 1 is 2 times 5x plus 4 over 2 times 5x plus 4, because 2 times 5x plus 4 divided by 2 times 5x plus 4 is 1, so we're not changing the value of this. However, we're manipulating that denominator in order to get it the same as our other rational. So notice that when we multiply this out, 2 times 2 is 4, so we'll have 4 times 5x plus 4. Therefore, we can then subtract our second rational, x minus 2 over 4 times 5x plus 4. So now looking at our numerator, 7 times 2 will be 14, so we'll have 14 times 5x plus 4 over 2 times 5x plus 4, which is 4 times 5x plus 4, minus x minus 2 over 4 times 5x plus 4. So now you can see our denominators are indeed the same, so we can subtract the numerators over the same denominator. And I'll go ahead and distribute this 14 while I'm at it. So 14 times 5x is 70x, 14 times 4 is 56, and then we're subtracting the quantity x minus 2, and that's all over 4 times 5x plus 4. Now I'll combine my like terms, 70x with x and 56 with 2. 70x minus x is going to be 69x, and then we'll be adding that to 56 minus a negative 2, so 56 plus 2, so that'll be 58. So we have 69x plus 58 all over 4 times 5x plus 4. And 69, 58, and 4 are all not divisible by the same number, therefore 69x plus 58 over 4 times 5x plus 4 is my solution in number 9. Let's continue on to number 10. In number 10, unlike the first problem where I only needed to multiply or manipulate one fraction, I'm going to have to manipulate both fractions. So I'm going to multiply 8 over 7v minus 6 by 1, and I'm also going to multiply 4 over 3v squared by 1. However, the quantities of 1s will be different. So I'll have 8 over 7v minus 6, and I'll multiply that by 3v squared over 3v squared. So the denominator of my other rational over itself. So 3v squared, 3v squared. And then I'll be adding that to 4 over 3v squared times, now I'm going to be multiplying it by 7v minus 6. So the denominator of the other fraction over itself. So 7v minus 6 over 7v minus 6. And I did this because when we multiply 7v minus 6 by 3v squared, remember multiplication is commutative, so that's the same as multiplying 3v squared by 7v minus 6. So now we'll have the same denominator. However, simplifying, 8 times 3v squared will be 24v squared, and that's all over 3v squared times 7v minus 6. And that first fraction will get added to 4 times 7v minus 6, where we can think of the 7v minus 6, that 4 is distributed to both 7v and the 6. So 7 times 4 will be 28v, and then I'm subtracting 4 times 6, which is 24, and that's all over 3v squared times 7v minus 6. So that was our second fraction. Now we'll just add the two together because we have the same denominator. So 24v squared plus 28v minus 24 all over 3v squared times 7v minus 6. So none of my terms in the numerator were like terms, so I could not combine any of those. And a 3 cannot go into 24, 28, and 24. Therefore, 24v squared plus 28v minus 24 over 3v squared times 7v minus 6 will be my solution in number 10. Now I know that 24, 28, and 24 have a number in common, so if you want to simplify those, feel free to do that by pulling out a 4 and then writing it as 4 times 6v squared plus 7v minus 6. However, it's not necessary for this worksheet. Let's continue on to the second page. Again, for number 11, just like in number 10, I'm going to multiply both my rationals by 1. And that 1 is going to be the other rational's denominator. So 7v over 8 will get multiplied by 5v minus 2 over 5v minus 2. And then we'll be subtracting that second rational, 8v minus 4 over 5v minus 2. However, we're going to be multiplying that by 8 over 8. So you can see that 8 times 5v minus 2 is the same as 5v minus 2 times 8. So I'll have 7v times 5v minus 2 over 8 times 5v minus 2, and then we'll be subtracting 8 times 8v minus 4 over 8 times 5v minus 2. And you can see that 5v minus 2 will cancel out with 5v minus 2 because that is indeed 1, so we will have 7v over 8. And if we were to cancel out the 8's, because 8 over 8 is 1, we have 8v minus 4 over 5v minus 2. However, the purpose of this is to subtract. That's why we had to create those like denominators, or those equivalent denominators. So now I can subtract my numerators, but I'll distribute first. So distributing that 7v and then distributing that 8. 7v times 5v will be 35v squared, and I'll be subtracting 7v times 2, which is 14v, and then subtracting the quantity, 8 times 8v, which is 64v, minus 8 times 4, which is 32. And that's all over 8 times 5v minus 2, because they're all over that same denominator. Now I'll simplify my fraction, combining like terms in my numerator. I can combine 14v with 64v. So I'll have 35v squared minus 14v minus 64v will be a negative 78v, so subtracting 78v, and then you can see that we're going to be subtracting a negative 32, so that's the same as adding a positive 32 in that numerator, and that's all over our denominator of 8 times 5v minus 2. So 35v squared minus 78v plus 32 over 8 times 5v minus 2. That's my solution in number 11. In number 12, again, we're going to be multiplying each of our fractions by 1. And remember that 1 will be the other denominator over itself. So 4 over n plus 7 will be multiplied by n minus 2 over n minus 2. And then we'll subtract 7 over n minus 2, that quantity multiplied by n plus 7 over n plus 7. So now you can see n plus 7 times n minus 2 is equivalent to n minus 2 n plus 7. So that's going to allow us to subtract our numerators. But first, let's simplify. So we'll have 4 times n minus 2 over n plus 7 times n minus 2, and then we'll be subtracting 7 times n plus 7 over n plus 7 times n minus 2. Now I'll distribute the 4 and I'll distribute the 7. So 4 times n is 4n minus 4 times 2, which is 8, and then I'm subtracting 7 times n, which is 7n, and I'm also subtracting 7 times 7, which is 49. Because I was subtracting this entire quantity, even though this 7 was added to the end, it's subtracted from our first rational. So you can think of that as distributing that subtraction to each of those terms. And that's all over n plus 7 times n minus 2. Now I'll combine my like terms, combining 4n with 7n and combining 8 with 49. 4n minus 7n is negative 3n, and then negative 8 plus negative 49 will give us a negative 57. So then I'll subtract 57 from that negative 3n, and that's all over n plus 7 times n minus 2. And that's my solution in number 12. In number 13, I'll simplify at the start. So I'll have 7 over, pulling out a 3n from each of these terms. That'll be n plus 8, because 3n times n is 3n squared, and 3n times 8 is 24n. And from this first rational, I'll be subtracting 7 over 2n. Now, just like before, I can multiply my first rational by my second rational's denominator over itself, and then I can multiply my second rational by the first rational's denominator over itself. However, I want to do something a little bit different in number 13. Notice that we have 3n times n plus 8, and we have 2n. Both of those terms are already very similar because we have an n in the denominator. So what I'm going to do is I'm going to multiply each of those fractions by 1. However, I'm going to manipulate them so I don't have to necessarily multiply by 3n times n plus 8 or 2n over 2n. So, for example, 7 over 3n times n plus 8, I need to make a similar denominator. And because my n's are already similar, it's my 2 and 3 that I need to find a common multiple of, and that's going to be 6. So if I multiply my first fraction by 2 over 2, I'll have 6n times n plus 8. And then I'll be subtracting my second fraction, 7 over 2n, but I'll be multiplying that by, I need to make it 6n times n plus 8, and I already have 2n, so I'll just multiply it by 3 times n plus 8 over 3 times n plus 8. So you can see that 3n times n plus 8 times 2 will be 6n times n plus 8, and 2n times 3 times n plus 8 will be 6n times n plus 8. And again, this is all to get a similar or equivalent denominator. So I have 7 times 2, which is 14, over 6n times n plus 8, and then I'll be subtracting 7 times 3, which is 21, times n plus 8, all over 2n times 3, which is 6n, times n plus 8. And then because I have an equivalent denominator, I can subtract. So I'll take 14 and subtract 21n, and subtract 21 times 8, which is 168. And that's all over 6n times n plus 8. And now I can simplify, combining 14 and 168. So 14 minus 168 is negative 154. So I'll have negative 154 minus 21n all over 6n times n plus 8. That is my solution in number 13. Now, quickly in 13, I'm going to show you that we would have gotten the same answer if we've been multiplying by 1 like we have in the previous problems. So I'll have 7 over 3n times n plus 8, and then I'll multiply that by 2n over 2n and subtract 7 over 2n multiplied by 3n times n plus 8 over 3n times n plus 8. So this would be equivalent to 7 times 2n is 14n, and that's over 6n squared times n plus 8. And then we'll subtract 7 times 3n, which is 21n, times n plus 8 over 6n squared times n plus 8. And then when you write those under the same denominator, because now we have 6n squared times n plus 8 and 6n squared times n plus 8, if you notice, in each of those fractions, we're multiplying n to the entire quantity. So we can take away an n from the denominator, and you can see that we were right back where we got in our previous video. 14 over 6n times n plus 8 minus 21 times n plus 8 over 6n times n plus 8. So regardless of what you did, whether you multiply by 2 over 2 or 2n over 2n, and the same with that other fraction, you will get the same answer in the end when simplifying. So let's continue on to number 14. In number 14, I have 6 over v minus 2, and I'll be multiplying that by 2v plus 7 over 2v plus 7, so multiplying by 1. Then I'll subtract 7 over 2v plus 7, but that multiplied by v minus 2 over v minus 2. So now I'll go ahead and distribute the 6, and I'll distribute the 7. So I'll have 6 times 2v, which is 12v, plus 6 times 7, which is 42. That's all over v minus 2 times 2v plus 7, or 2v plus 7 times v minus 2. And then I'll subtract 7 times v, which is 7v, and then 7 times 2 subtracted, that's subtracting 14. So subtracting 7v minus 14 over 2v plus 7 times v minus 2. Now that I have the same denominator, I'll be able to simplify by subtracting this numerator over that denominator. So I'll have 12v minus 7v, which is 5v, and then I have 42, and I'm subtracting a negative 14, so 42 minus a negative is the same as 42 plus a positive, so that's 42 plus 14, which will be plus 56, so I have 5v plus 56 in my numerator, and that's all over my denominator of 2v plus 7 times v minus 2. That is my solution in number 14. 5v plus 56 over 2v plus 7 times v minus 2. And number 15, I'm going to start by simplifying. So I'll have 6x over 3 plus 7 over, pulling out a 3 from that denominator, I'll get 5x plus 1. And the reason I didn't simplify 6x over 3 is because that I knew I could pull out a 3 from this denominator. So now all I need to do is multiply that first fraction by 1. So if I have 6x over 3, I'll multiply that by 5x plus 1. And then I'll have the same denominator, because 3 times 5x plus 1 is 3 times 5x plus 1. So I'll add 7 over 3 times 5x plus 1. Now simplifying, I'll distribute the 6x to get 6x times 5x is 30x squared. 6x times 1 will be plus 6x. And then we'll be adding 7 to that, and it's all over that same denominator, 3 times 5x plus 1. So that is my solution in number 15. 30x squared plus 6x plus 7 over 3 times 5x plus 1. And again, we only had to multiply that first rational by 1, in order to manipulate it because we already had a 3 in the denominator of our second term. But in our first term, we were lacking that 5x plus 1, so we multiplied by 5x plus 1 over 5x plus 1. Now, on to number 16. In number 16, I'm going to be multiplying each of those fractions by 1. So I'll take 5v over v minus 3 and multiply it by v plus 6 over v plus 6. And that will get added to 5 over v plus 6 times v minus 3 over v minus 3. So you can see that in my denominator, v minus 3 times v plus 6 is equivalent to v plus 6 times v minus 3. So I'll have 5v times the quantity v plus 6 plus 5 times v minus 3, 5 times the quantity v minus 3, and that's all over v plus 6 times v minus 3. So now I'll simplify that numerator. I'll need to distribute my 5v to the v and to the 6, and then I'll need to distribute my 5 to the v and 3. So 5v times v is 5v squared plus 5v times 6 is 30v plus 5 times v is 5v minus 15. And that's all over v plus 6 times v minus 3. Now my last step is to simplify by combining like terms. I can combine 30v with 5v. So I'll have 5v squared plus 35v minus 15 all over v plus 6 times v minus 3. That is my final solution in this video. If you have any questions, please feel free to leave them in the comments below. And before you continue on to the next video where I'll finish this worksheet, remember to click that like button, subscribe to my channel, and share this video with your classmates.